Okay, guys, so this one would definitely use, you need to know how to use your graphing calculator for a scatter plot, okay? A farmer collected the data, which is given to us at the table to the right, which shows crop yields, which represents Y, for various amounts of fertilizer used, which is X. Part A says, use your graphing calculator to draw a scatter diagram. Sketch it and comment on the type of relation that may exist between the two variables. So please take out your calculator, and this is how you are going to use your graphing calculator to do a scatter plot. First, I want you to find the button that says stats and press it. Once you're in here, you're going to see edit, calc, and test. Under edit, I want you to hit enter on edit. In here, to save some time on the video, I've already entered all of the 18 data set from our problem. Remember, the plot here, 1, 2, 3, 4, 5, 6, 17, 18 here, those are not relevant for us. We only need to enter in the inputs and the outputs. So that means the fertilizer amount, okay, which is 0, 0, 5, 5, and so on and so on. You need to go all the way down to 18. And the last, and you can see here, I'm just, again, I entered that in already. The last couple of fertilizer amount, stats, I lied. Okay, the last few amounts, as you can see, are like the 240s, okay? Once you hit all of the X values in, then you're gonna go to the right and then enter in all of the bushels as yield. Again, similarly, to save some time in the video, I've entered all the way to 22. I still have some more to go. So the next one I'm going to enter is 21. Hit enter. Then 20. 20. Enter. 19. Enter, and 19 again, enter. So the data set for L1 and L2 students, they need to be exactly the same, okay? So now part A says, use the graphing utility to draw a scatter diagram of the data. So how we're gonna do this is gonna do hit stats again. I want you to go over and go to calc. First, I want you to run a linear regression, which is number 4. So hit number 4, and you're going to see this screen right here, and we're going to go down to calculate, and we're going to store this regression. To store it, we're going to hit vars, find the vars button, and go to yvars. There you go. Go yvars and go down to function with just 1, and let's store in y sub 1. So hit enter on that one. And yes, go down to calculate, hit enter. So here's where we're at. Now, to see what this looks like, we're gonna go to your graph, okay? We're gonna zoom, but we wanna do zoom stats. Zoom stat is number 9, so we hit number 9. We wanna see if the data set fits your, fits the linear, okay? So, oh, you know what? I didn't highlight plot 1. Can you go up and hit enter in plot 1? Now do zoom and zoom stats again, which is number 9. Okay, so based on this data set, we have a linear in there. It looks okay, but we also want to run an R-square. So can you guys do this for me to run an R-square? Hopefully this is the same as my regular calculator. Okay, we want the catalog. So second catalog, and we want diagnostic on. So I'm gonna go all the way down. Let's find the D. Diagnostic. Oh, come on. DI. Did I see I yet? Oh, here we go. Okay, hit on right there. Diagnostic on. Hit enter. Hit enter again. Okay, so now let's go back to zoom. Zoom. We want to see the stats. My bad. Hit stats. Go to calc. We did linear regression, which is number 4, and go to calculate. Okay, it gives us, guys, it gives us an R-square now. An R-square is how good it is to the data set. So right now it's 0.76. That's kind of like 76%. So when we went to zoom and zoom stat, which is 9, okay, so that's a line. Let's do the let's run the regression again. Hit stat, go to calc. We now want a quadratic regression, which is number 5. And let's see let's store it. Let's vars. So vars, go to y-vars. Yes on none function. Yes on 1. And let's go calculate. Okay, so r squared now, student, is 0.949, which is almost 95%. Let's choose zoom and zoom stats. Oh, that looks so much better then, isn't it? So that percentage is higher than the linear. So I believe the regression is a better fit, okay, because it has a higher r squared value. Let's go back. Use your graphing calculator to draw a scatter diagram. Sketch it and comment on the type of relation that may exist between two variables. Okay, so we are going to sketch it. And when they say sketch it, I do want you to sketch it. Okay, your X is going to be fertilizer, label your X-axis and Y-axis. Okay, and then your Y is going to be the bushels yield. Okay, we are starting at 0 up 4, so it's going to be something like that. And it's going to have a bunch of dots in a quadratic. So, okay, pretend that's this. Okay. And it says comment on the type of relation. It is going to be a quadratic relationship. Okay. Okay. Use your graphing calculator or decimal to find the quadratic function of best fit, which, guys, we already found it. So let's go back to my calculator. And okay, so we ran it already, stats, and we went to calc. We went to quad regression, which is number 5, and we're gonna hit calc. Okay, as you can see, it's ax squared plus bx plus c. Okay, now if we look at this, we have an a, which is a negative 0.01712. We don't know. I didn't really type in what the rounding was, so the numbers are really small. So let's round to 4 decimal places. Okay, I'll be more precise if it's an exam or something. Okay, so your quadratic regression was ax squared plus bx plus c, and it gave you your a, b, and c values. So now we just have to copy it in. Y equals, it gives you a negative 0.017. We want 4 decimal places, so that would be 0.17, and I believe after that is a 1. Okay, and then x squared, and it gives you a b of 1.0765, so plus 1.0765. Keep it consistent with 4 decimal places. Okay, then the c value was 3.8939, so plus 3.8939, and box that up. Now to get the rest of our answer, I want you to store it, okay, to your y equals, so that way we have a better, more accurate information. Use the function found in part B to determine the optimal amount of fertilizer to apply. Okay, do not round until the very end. That means I want you to store it in your y sub 1. Again, we'll run it again for you and show you how to store it. Hit stats, go to calc, run the quadratic regression, which is 5, go down to store regression, hits vars, go to y-vars, hit function. Technically, you can store in any one of these, but I always store in y1 and go down to calculate, hit enter, and then go to y equals. See, it's already right there for you. You don't have to type anything in with all the decimals. Hit zoom and zoom stat, which is number 9. And then now this is what we have. We want the optimal amount, so we're going to trace for the maximum. So second trace maximum, which is number 4. Right bound sounds about right there. Okay, hit enter, go over. Okay, let's go over here. Okay, so now it wants it to put the cursor to the right bound. All right, so it looks like 3.44 is the x. Okay, it looks like we have 3. If I read on more decimals, then it's gonna say, the calculator says 31.438052. That's the x, and the y is 20.81571. So we can go back to our notes. Use the function found in part B to determine the optimal amount of fertilizer. Remember, fertilizer is the X value, so we only need to answer the X value, okay? And the unit of that is pound per 1,000 foot square. So let's write that. It's going to be 31. Do we want to round to 2 decimal places? Let's keep it. So that means it's 44, and the unit for X fertilizer is pounds for every 100 foot square, okay? Use the function we found in part B to determine and predict the crop yield when that amount of fertilizer is used. And that was the Y value, guys. So the Y value was 20.8. If we run to 2 decimal places, is 2, since the third digit is 5. So what's the unit for Y? Bushels. Okay, so 20 bushels will be produced if we use the 31.44 pounds per 100 square foot of fertilizer. Sketch the quadratic function best fit on the same graph as part A. Okay, so they'll go up, and let's go. It's not starting at 0, 0, so okay, like that. Okay, and that, I believe, answer all the parts. Yeah, that is it.